Okay, we're back in the shop, and today we're going to repair this line, hopefully, and get it back on the Bronco and give it a good charge. So here's our problem child right here. So this fitting is where I was seeing oil sign and dye, and if you look at this, I can twist this very easily inside of the rubber hose. That's a pretty good indication that it wasn't tight enough. And as I mentioned in the other video, this is actually a problem with Fords in particular, especially Fords that were made in the late 80s and early 90s. And I actually ran into that same problem on this other fitting, and I had to make this repair. So my intention is to do the exact same thing on this end, but before we do that we need to get it apart and just kind of look at these pieces and take some measurements and see if I can scrounge up a piece of steel that I can use to make a piece that will fix this particular problem, which I'll show you in just a minute what's going on with these Ford lines. So let me clamp this on the vise and I'll cut the ferrules off and we'll take a peek at it and see what we can see. So you notice how that's kind of hourglass shaped. And this is what happens to these older Ford lines. For some reason these older Ford lines are made out of a steel that's very thin. It's almost like they're stamped. And with time, what happens is that joint will collapse and start leaking. And this is a very common problem. I knew that this may happen. I've seen this before. And when I built these lines before, I just kind of shrugged it off as, well, we'll give it a try and see what happens. And if it doesn't work, I'll just have to repair it later. In hindsight, I wish I would have done it correctly the first time around, because refrigerant is about twice as much now as it was then. But that's okay, we'll go ahead and fix it this time. But before we do that, let's take the other side apart and I'll show you how I repaired that side. So here is this manifold block that bolts to the compressor, and you can see I had to actually bend it a little bit to get it to work in this Bronco. And this is the part that I actually manufactured to fix this particular Ford issue with these lines. And basically it's just a piece of bar stock that I whittled down on the lathe. It's a little bit thicker than the factory steel is. And I cut some barbs on the lathe, and there's a little shoulder for the ferrule to grab onto. And then the other side was just bored to fit the outside of that sheet metal line. And I attached it. We'll get into the attachment method after I get this piece cut. For now, I need to whittle out another one of these on the lathe, so we'll do that next. But before I do that, I need to whack this substandard part off of here, and then take a measurement on this sheet metal, this outer diameter, to see what I need to cut the new one to. Okay, I'm going to take a quick measurement of that Okay, so the outer diameter of this piece is exactly half an inch. That's about 12, almost 13 millimeters. And then the inside diameter of my line, let me use a piece that's completely unmolested here. Is 10 millimeters, which is about 399 thousandths of an inch. And PC hoses come in different sizes. The most common ones that you'll find on vehicles are 6, 8, 10, and 12. And the manufacturers will choose the size of the hose based on what's going on, where it is in the system, and whether the refrigerant is a gas or a liquid at that time. So it's based on liquid, gas, or state, and then it's also based on pressure. So for instance, by using that information, we can determine or make a pretty good guess that the high pressure liquid line would probably be the smallest hose on a typical vehicle. And it is. It's typically number 6. And then the largest is going to be a low pressure gas line, which is the line that's between the evaporator and the compressor. And that's usually a number 12. And then everything in between is just, in between. This one happens to be a number 8. And there's 2 different types of hoses. There's a standard diameter hose, and then there's a reduced diameter hose. And most of the older vehicles use standard. Most of the newer vehicles use reduced. And there's quite a bit of difference in it. This is a piece of number 8 reduced, and you can see, compared to the standard, it is vastly different in outer diameter, but the inner diameter is the same. When I build lines, I will typically use the standard stuff if I can, because when you're crimping on a hose, if you have a lot of rubber to crimp against, things become much less critical. So if you don't do a perfect crimp, or your barb isn't perfectly shaped, you can usually get away with it because there's so much rubber to compress there that it will seal. Things are much more critical when you're using a reduced diameter barrier hose, because there's just not as much rubber there to crimp against, so you have to be really careful when you make the crimp and design your fittings, etc. So these 2 different types of lines take 2 different types of ferrules. And I needed to know this ahead of time because my crimping set is a standard die crimping set. And it's got dies for 6, 8, 10, and 12. So what I did is I measured a number 6 standard, which happens to be very close to the same diameter as a number 8 reduced. So I think I can use the number 6 standard die to make a number 8 reduced crimp. We're crossing our fingers on this one. I've never tried this before, but it should work. And then the only other problem we're going to run into that I can see is that when we're building these, we have to engineer a little step in the line. And you can see I've engineered that step right there, so that when we put this fitting on, there's a little edge for this fitting to grab onto so that the line doesn't blow off. And that's pretty critical. You really need that. You can't trust just the crimp alone, because as you notice, this fitting that I just took apart, it wasn't holding on very well. It could have blown off if there wasn't an edge there for it to grab onto. It probably would have blown off. But obviously we can't slide that over. So what you have to do is you have to regrind this edge right here so that you're only using one side of it to hook over this step. And usually that's enough. So it looks like I'm fine with this. I probably have a number 8 standard. Well, I don't, but this is a number 10 or number 12 standard. I think it's a number 10. So this is good for illustration purposes. This one's, you can see how that hole is offset. And in this case, this is the edge that would hook over the step in the steel portion of this barb and hold everything together. So we'd assemble this by sliding it up over, hooking that edge, and then slide the rubber hose in there and do a crimp. And that would only be holding on one side, but that's enough. Okay, so I think we have enough pieces to get this done now. And now I just need to find a piece of soft steel that I can use to make my adapter. And I honestly couldn't find a piece of soft steel. I did find this bolt, which is big enough that I can grind it and cut it down to what I need. But this is a 10.9 hard bolt, which is pretty hard. They start at 8.9 and go up, or 8.8 and go up. So this is like one step above a grade 5 bolt. So in order to not have to be so careful with my tooling, my carbide bits and such, I'm going to anneal this. I'm going to dig out the acetylene torch and I'm going to heat this up so that it's cherry red and or cherry orange, and then we'll let it air cool naturally, and that will take that temper out of it and make it soft. So we'll do that next. I'll grab the acetylene torch and drag it out and clamp this thing in a vise and heat it up. And we'll let that air cool. It's cool now enough that I can start machining it. And the first thing I'm going to do is just whack the head off, because I don't want to cut that down on the lathe. That would take forever. Let's chuck this up in the lathe. So this part's going to have to be gun drilled, which it's kind of a difficult machining operation because you have to drill straight holes. I'm not real good at drilling straight holes, so what I'm going to do is I'm going to drill half of it from this side, then flip the piece over and drill the other half from the other side. Man, that was my favorite drill bit too. That was entirely my fault, by the way. I ran the bit past the flutes. I'm going to work on it from the other side a little bit. I'm thinking since it bound up right at the end of that I can probably drill the other side and then knock it through with a punch. I'm looking to see if the color of those chips changed. I would think that if I got into a hardened drill bit that the tone would change. I should be really close. Yeah, I got it really close. I measured the diameter of the hole in the line that I built before, or the adapter I built before, and it's exactly 1/4 of an inch. So I'm going to go ahead and take this one up to that dimension. I'm up against that broken bit now. I felt it. I'm going to see if I can find something that'll fit inside there, and I can maybe clamp that in the vise and just knock this broken bit out with a hammer. Well, I don't have a punch that long. I've got them that diameter, but I don't have them that length. So I'm going to try and tap it out with a drill bit. Well, I'm getting it. Okay, hopefully I can finish this without any more drama. I just need to figure out where I'm going to put the step, and I really only need as much as that ferrule is in length, but I think I'm going to go a little longer. So I'm going to put the step right about here. And that should be good enough. So I'll cut a step in there. The rest of this dimension has to go down to 430 thousandths. That's the inside diameter of the hose. But I have to leave room for barbs. I will do that, and then once I do that, I'll flip the piece over and I'll drill a 1/2 inch hole in the other side so it'll slide over that sheet metal line that I'm working with, and do a little cleanup, and then we'll be done. Well, the surface finish wasn't looking very good, so I went ahead and I changed out the bit. I think I can go ahead and cut the barbs. and a step. Okay, the next step is just I need to grind these ferrules so that they will slide over this step that I've made. When we attach our line, that centers everything up so that it can't come off. One down, one to go. Okay, ferrules are cut. Both of them work well. And now we get to our attachment method. And there's several different ways I could do this. I could epoxy it. And good epoxy made for air conditioning would probably hold just fine, but this is on the condenser where it gets quite hot, and plastic and heat don't really go together that well. I could weld it. I have a MIG welder and a TIG welder, so either one of those would probably work just fine. And I have MIG welded lines on that truck already, but in this case, because I have such overlap between the two parts, I think brazing would be the best option. So brazing would give me a better seal. Brazing doesn't have the physical strength of welding, but since I have so much overlap between these two pieces, this would work just like solder. The braze will get down in between these two parts and give me almost ½ inch of sealing surface, which is a much better repair when it comes right down to it. If you do braze right, it will flow just like solder. And here is the finished product. So what I like about brazing is when you get the metal hot enough, you just put the brazing rod up there where you want it to go, and it will melt and it will wick down in the part just like solder would. So that is actually a very good repair. So it wicks down inside this part as far as those two metal surfaces are overlapped, and you can see that there's no gaps there. So as far as making an airtight seal, this is a really good way to do it. Okay, we're almost at the end of our fun. I've got my crimper set up there, getting it set up. And I noticed something when I went to get my number 6 die. So this actually has two sets of numbers on it. It's got number 6 at the top, and then down below it says 8 SRB. I can only guess that the SRB, the RB must mean reduced barrier. So this die is already set up, or this press is already set up to do number 8 reduced barrier hose. It's the only one that's like that. None of the other ones have a dual stamp like that, but this one does, so I kind of lucked out. Okay, this line sits in the track at about a 45-degree angle, about like that. I'm just going to follow that natural curve. I've already cut this to length. So this hose has a natural curve. It comes off and rolls. So it's going to snake up and then over. So right about like that should be good. So the instructions say to never put an impact on this. I was never very good at following instructions. That's got a good grit. I cannot spin that at all. And the edge is over top that lip, so that'll... right about like... Maybe lay that down just a little bit. About like that. Yeah, that's pretty close. Now you notice there's always a little hole in these ferrules, and the purpose of that is just so you can see when you're up against the hose. Otherwise you would never know. Double check that one more time. Okay, 45. That's pretty close. Here we go. Once again, if I try and spin this, I cannot. So the next step is for me to go ahead and bolt this back on the truck. I'll do that real quick. And this is what the finished installation looks like. You see that line snaking underneath the air intake. And then over here. And in case you haven't figured it out by now, it should be pretty obvious why I wanted to use reduced barrier hose here. And I'll edit in a picture of what it looked like before so you can see the difference. This was pretty tight in here. And this reduced barrier hose fits that space so much better that I hope that is a better solution than the other one was. Seems like it will be. Okay, now I have to pull out a vacuum, and in order to do that I'm going to use one of these air vacs. So I'll go ahead and hook this up. I'm not going to video that because it's very noisy, but once we get it pulled in the vacuum we will reconvene. Got it pulled the vacuum, and now just real quick I'm going to put oil in it. This is a 3-ounce can of oil. And I figure I probably lost an ounce or two with the leak. So these cans have a little bit of refrigerant in them, and it will just push the oil into the system. And I try and do that as quick as possible because the longer you leave it in the vacuum, the better chance of screwing up and letting air back into the system. So I want to try and get this thing into positive pressure as quick as I can. So this is just a partial can. I did my math right. These systems took about 3 pounds of R12. Yeah, about 3 pounds of R12. And as a general rule, you want about 70% of that in R134. So 70% of 1 is 7/10 times 3 is 2.1, so we need about 2.1 pounds. Unfortunately, these cans are 12 ounces, they're not 16 ounces. So it's going to be more than 2 cans, I think, at the end. Luckily, I have a switch, and the switch will kick the condenser fans on at like 320 psi, 330, somewhere right around there. So I'll just add refrigerant until the condenser fans kick on, and I know we'll be close. Typical generalization with AC is it's going to cool half of whatever the ambient temperature is that's going across the evaporator fins. So if the air across the evaporator fins are 100 degrees, then I would expect to see 50 degrees out of the vents if the system's working correctly. That's one of the reasons why, especially here in the desert where it gets really, really hot, ambient hot, you never want to start up your car after it's been setting outside and then go straight to max air or recirc mode on the airflow. And that's simply because when you do that, it's pulling the air from under the dash that's inside the car, which is significantly hotter than what's outside the car. And you can imagine if the air underneath the dash is 140 degrees and you can only cool half that, you're only going to be blowing 70-degree air out of the vents and it'll feel warm. So at least for the first 5 or 10 minutes you want to run it in vent mode, or not recirc mode, or not max AC mode, until you expel all that very hot air out of the car, and then you can flip it over to max AC or recirc and it'll work better for you. But I'm going to call this one done. It's cold enough, it's much better than it was before, and I'll keep an eye on it, make sure it doesn't leak, and we'll catch you on the next video. Thanks for watching.